Hey folks, the law of cosines. So as complicated as the ambiguous case was for the law of sines, the law of cosines is very straightforward. So in any triangle, so again, we're opening this up. This does not have to be a right triangle. This could work. This law works for every triangle. And then we have, it looks kind of like the beginning of the Pythagorean theorem, a squared plus b squared equals c squared, but then we subtract off this 2ab cosine of big C. I don't know where, I've never taken the time to look up proof of the law of cosines, so if you're interested in why it works, I'm sure there's tons of proofs out there if you want to Google it and see for yourself. So there's always, you can look at the law of cosines from any perspective, any one of the sides. So it's traditionally written as c squared equals a squared plus b squared minus 2ab cosine of big C. But you could also put the little a there. Now you can do that. These are going to change into b's and c's. And then this is going to be the big A. So just to relate, whatever you want to put here, as long as you have that angle at the end, life is good. So let's just rewrite those other two, the other two perspectives of the law of cosines. So instead of being c squared, I could start with b squared. Now, if that's a b, then these have to be a's and c's. So a squared plus c squared minus 2ac cosine of big B. And then we have a squared equals, so now I have b squared and c squared left for those, minus 2bc cosine of big A. I'm going to go to my unit circle. I think I forgot to say that in the law of sines notes. So I'm going to go over here. I'm going to add the law of sines and the law of cosines to my unit circle. So the law of sines was sine of big A over little a equals sine of big B over little b equals sine of big C over little c. And then I'm going to write the three different styles of law of cosines. So a squared equals b squared plus c squared minus 2bc cosine of big A. B squared equals a squared plus c squared minus 2ac cosine of big B. And then c squared equals a squared plus b squared minus 2ab cosine of big C. And believe it or not, I think this is the last thing that we're going to add to our unit circle. Ooh, I think we should get this thing framed or maybe laminated so we can take it to college with us, huh? Amazing. All right, anyway. So like I said, these are pretty straightforward. Notice it just says this time, find little a. If you have to solve it, you'd have to go and plug and chug and find all of them again, but I'm not going to do that with you. You know how to do that from our law of sines. So we're just going to find one of them. So you know you're going to do the law of cosines when you're dealing with three sides and only one angle. So if I want to find little a, I only know little b and little c, and they gave me the angle across from it. So if I set this up, I couldn't do this with a law of sines. It'd be impossible because I don't have big B, I don't have big C. Let's just do a quick little chart. Big A, big B, big C, little a, little b, and little c, and we fill in, we know little b is 9, little c is 12, and big A is 25 degrees. See how none of them match up? We don't have any combination of big A and little a, or big B and little b, or big C and little c. That's why this has to be, you must use law of cosines. Another way that I knew I'd have to use law of cosines is they wanted me to find little a. And anytime you need three sides and one angle, that's the law of cosines. See how we have a, b, and little c, and then only one angle of big C. Anyway, all right, so let's set it up. So I'm going to plug and chug here. Okay, so c squared, for us, we're going to start with the a squared because that's the value that we're trying to find out. So a squared equals b squared is 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25 degrees. So this is just a matter of getting little a by itself. So I'm going to compute this all, figure out what that is. Clear. 9 squared plus 12 squared. Subtract 2 times 9 times 12 times cosine of 25 degrees. That's a hint. That's a reminder before I hit enter. I'm going to check my mode. And I'm in degree mode, so that's good. I can quit back out. Now I can hit enter. All right, so y is 29. This is approximately 29.2324. 29.24. Why is that not the answer? Because that's equal to a squared. We don't want a squared. We want little a. So I still need to square root, and we get little a is approximately equal to, and you don't need to worry about the plus or minus because this is not a triangle in the coordinate plane. This is just a triangle in two-dimensional space, so we don't really have a orientation. So positives or negatives don't apply. Now, how do I square root this number without rounding it? Well, I go second square root and then second answer. That's going to take my last answer and it's going to square root it. 5.41. Or if I wanted to, I could, let's say I go back here and I get this answer out there again. I could also go to the power of, what power is the same as square root? Power of 1/2. That would give me the same answer of 5.41. Either way is fine. All right, so like I said, that's pretty straightforward. This one's a little sneakier. Find big C if little a equals, little b equals, little c equals. Right away, I know that's law of cosines because there are 3 sides. Law of sines needs 2 sides and 2 angles. Law of cosines is 3 sides and 1 angle. So we need big C, so that means my equation is going to start with little c. So that's 8 squared equals a squared plus b squared minus 2ab cosine of big C. Now, it kind of feels like we could grab our calc and start to type all this in. The problem with doing that is you're not following the order of operations. How are these two connected? Add. How are these connected? Mult. And then how is this group connected to this group? By subtract. So I have to do all this mult first, and then I have to do this subtract, and I can't combine them because this stuff is still connected to cosine of C by mult. So you have to clean this up in little pieces at a time. So I'm going to start with this. I'm going to multiply those together. Then I'm going to take these, I'm going to clean up just this part. I'm going to multiply that together. So now we have, so 8 squared is 64. Then 14 squared plus 19 squared ends up being 557. Minus 2 times 14 times 19 ends up being 532 cosine of big C. All right, the number one mistake kids will make is they'll put these two things together. That's not legal because this is connected by multiply, so you have to solve, you have to peel things away. So the next move would be to subtract 557 from both sides. 64 minus 557 is negative 493. Now these are gone, but this is still then a negative 532 cosine of big C. Who's farthest away now? Negative 532, that's connected by mult, so we can kill it with division. So negative 493, I already had it in there, divided by negative 532 ends up being 0.927 is equal to cosine of big C. But we're trying to get big C by itself, so now we have to kill cosine, and we kill cosine with cosine inverse. Now we want to get as exact of an answer as possible. So if you cosine inverse 0.927, you're going to get potentially a rounded answer. So instead, I recommend taking that 0.927 and replacing that. So how could I do a cosine inverse of what would be the same as taking this answer, cosine inverse of your answer from before? So in other words, I recommend using the answer button in this situation. Replace this with answer instead of that decimal, and then we get an answer that's as close as we possibly can get, 22.08. So then we would say that big C is approximately 22.08. This is an angle, so don't forget your degree symbol. So law of cosines, a couple things you got to be careful of. Don't forget you got a square root. And then don't forget that you've got to solve for the angle. You got to peel things away. You can't just type it all into your calculator at one time. All right, good luck.